Now for this question, we're given that 9x squared all over x minus 1 squared times 2x plus 1 is identical to these partial fractions, and asked to find out what the constants a, b and c are. Now I'm assuming that you're familiar with partial fractions, but if not, you can always go on my website and have a look at the tutorials there. But essentially what you can do is multiply both sides by this denominator here, x minus 1 all squared times 2x plus 1, to each of these terms. If you multiply it on the left hand side, you're going to end up with 9x squared. And if you multiply this first term by x minus 1 all squared, 2x plus 1, then this x minus 1 is going to cancel out with one of these factors here and leave you just with a times x minus 1 times 2x plus 1. And if you do the same for this term here, it's the x minus 1 that gets squared, that gets cancelled out. So you're just left with b times the 2x plus 1. And for the last term, c over 2x plus 1, if you multiply it by the denominator here, it's the 2x plus 1 that gets cancelled out, leaving you with c times x minus 1 all squared. So we'll just put that in there. Now when you get to this stage, there's many ways that you could find your constants a, b and c, but the most common way is to try and make one of these factors equal to 0. So if we were looking for this term, we could make, say, x equal 1, and it would take out this term because we'd have 0 here. So if we let x equal 1, then we've got 9 times 1 squared, that's going to be 9, so we just therefore have 9 equals, as I said earlier, if you put 1 in here, this goes to 0, 0 times anything takes that out to 0. Put x equals 1 in this one though, and you've got 2 times 1 is 2, plus 1 is 3, so you end up with 3b. So you get equals 3b there. And when x equals 1 in here, this goes to 0, and so the whole term is 0. So from here we can work out what b is. Just simply divide both sides by 3 and you end up with 9 divided by 3, which is 3. So there's our first constant, b equaling 3. We can get the next constant, or another constant, when x is minus a half, because that will make this bracket here 0 and this one too. So it would just take out all of this term and leave us with this term. So would let x equal minus a half. So if we do that, what do we end up with? Well, a half squared, or minus a half squared I should say, minus a half when you square it is going to be plus a quarter. 9 times a quarter is just going to give me 9 quarters, 9 over 4. And that's going to equal, well, as I said, this term goes to 0, so that's taken out. This term goes to 0, and then here we've got minus a half minus another 1, that's minus 1.5, or minus 3 over 2. Square that and you've got plus 9 over 4. So you've got 9 over 4 times c. And if you divide both sides by 9 quarters, then therefore c equals simply 1. Okay, well you've got your b and your c, we just need to find out what a is. And again, many ways that we could do this. We could substitute another value for x into here. You can choose any value of x that you like, and you should end up with exactly the same value for a. I'm going to choose x equals 0, okay, as one way of doing it. But do try other values and check that you get exactly the same result. So if I choose x is 0, we've got 9 times 0 here, which is going to be 0, so that makes that simple. 0 equals, and in here we've got 0 minus 1, so that's minus 1. We've got 2 times 0 plus 1, so that's just simply 1. Minus 1 times 1 is minus 1, so you've got minus a for that first term. So put that there. Come on to this next term here. 2 times 0 is 0, plus 1, so that's just 1. Oh, you got 1b. But we've already found out that b was 3, so you've got simply 1 times b, 1 times 3. And then for this last term, x is 0, so you've got minus 1. Minus 1 all squared is 1. 1 times c is going to be 1. I'll just purposely put 1 times 1 in there though at the moment. But if we add a to both sides, you find that you get a there equals 3 plus 1, so a is 4. As I say, it's not the only way of calculating, say, a. You could compare the coefficients, say, of x squared in this identity, or x, or the constants. Look, I'll just compare the coefficients of x squared and leave it to you to try the other ways and see how you get on. But it'll just give you an idea, hopefully, how we go about that, or a reminder anyway. Compare the coefficients of, say, x squared. What we're trying to avoid though is simultaneous equations all the time, complicated equations, and if we can avoid it by substituting certain values in and possibly comparing coefficients, then, you know, suitable coefficients, then hopefully we can avoid complicated equations. But if we compare coefficients of x squared, we've got the 9 here, okay, equals, and what are we going to get here when we expand this? Well, you're going to have 2x squared times a, so you'd have 2a as a coefficient of x squared, so we'll put 2a there. When we look at this term, we're not going to have a coefficient of x squared. When you expand this, you're just going to get 2bx, which is a coefficient of x, and 1b, which is a constant, so we end up with nothing from that point of view. But here, if you're to square the bracket, you're going to get x times x, x squared, times it with a c, so you're going to get cx squared. So the coefficient there of x squared would be c. And we'll just put the c there in. But we know that c is 1, so therefore we've got 9 equals 2a plus 1. And if we take 1 from both sides, you get 2a equals 9, take 1, which is 8, and if you divide both sides by 2, you end up with a equaling 4, which should be what we expected. Okay, so do try comparing coefficients of x or constants. Compare your methods. That's the best way to learn this kind of work. Okay, and anyway, at the end of the day, our constants then are, if we summarize, are a equals 4, b equals 3, and c equals 1. Alright?